All right, so AWS has recently released this XKS feature or external key management. So I just do want to do a quick demo in terms of how does it work. Right, again, firstly, is log into our CipherTrust Manager. As you can see, basically, our CipherTrust Manager has a rich feature in terms of data discovery classification, as well as transparent encryption, and so on and so forth. Right, today we're going to zoom in into cloud key management. Right, so once we zoom in this CCKM or cloud key management itself, we can see this. We have a rich capability of not just managing AWS key, but also Azure, Google, Salesforce, and so on and so forth. Right, so for this hold your own key feature itself, basically the configuration is actually done at the AWS account. And then once you go into the AWS KMS account, then you can see the what do you call it, the external key store being configured, right? So I have already configured those early on. So maybe next time I will just we'll run through the details. But basically for this quick run through, basically I already configured this key store, which is created a key store which linked to the AWS account itself, right? So once I created a key store itself, basically this is the external key store. And you can see basically I created two keys and they are in hold your own key feature itself. And we can actually validate that with the AWS console itself. So from the AWS console itself, now basically you can see this is the hold your own key or XKS is called actually external key store, right? So you can see basically when I log into my AWS account, once I created a CCKM connected key store, you will see this external customer key store now available under your KMS capability. So I think the beauty of the what do you call the enhancement of the AWS has done on the hold your own key is basically apply this hold your own key feature to support most of the AWS services, including S3, EC2, or RDS, and so on and so forth. Right. So once I have the what you call, of course, I need to go through those configuration during the creation in terms of pointing to my CipherTrust Manager, as well as this is actually automatically generated when I using CCKM to create this external key store. Right. So maybe next time I can show you the details in terms of creation. But today I'll just do a very quick demo in terms of how these external keys can be used to encrypt S3 objects, right? So yeah, this also some reporting you can see in terms of the external key stores that AWS keep track of. Because once you use hold your own key feature, which means your data workload actually need to go to the external key store in the encryption decryption process. So the connectivity and availability is very critical for your workload. Right. So I would just what do you call show you in terms of how we use this, let's say in the S3 kind of scenario. So in this case, actually, I have configured two files. One is called security PDF, and then I have configured this APAC hold your own key what do you call folder, S3 folder, to utilize this actually this particular key, which is actually the my hold your own key keys, because once you click this one, it will bring you to that particular external key, which is this particular strong hold your own key. And this is actually this particular key created from external key store, because this is different compared to the usual keys. Basically, you will see the key material stored locally. Basically, here you will see the configuration of where is the external key store, and uh, yeah, where is the external key store configured, and how can it be called, right? So basically, this is the external key store ID, and then that will link to my CCKM configuration just now. Right. So with that, actually, I can do my usual downloading what they call with that actually the files I can actually do my usual things like download a file from this key store, right? So this is a simple PDF file, right? So basically, if the key store is enabled, basically I can actually continue download my usual files. So the difference here, basically, we will actually see a record. Right. So actually, the AWS will call the CipherTrust and then use the key and then read from the CCKN KMS and then decrypt the data and then provide the information. So the difference here is basically once we use a hold your own key feature, the control is all in your own hand, right? So basically, this key now is not stored in AWS key store, but in your own key store, the CipherTrust Manager itself. It can also be connected to the Luna HSM if you prefer that way. So I can what do you call it? The control is all in customer hands, right? So I can just block the key in this case, right? So if I block the key itself, which means the um, uh, the key is no longer accessible, or for this particular key is no longer accessible from this AWS calling. So in that case, basically, right, we will see what happened to this AWS share, right? So if we go back to this bucket, right? So this is the APAC for your own key bucket. Where is it? And I will say, oh, I want to download this file again, right? So you can see basically now you encounter error, right? So the external key associated is not enabled, right? So basically, actually, AWS is calling CipherTrust Manager to trying to decrypt the data, right? So another proof of that is basically you can go to the AWS CipherTrust Manager itself to see the calling request, and this is now basically what they call the AWS actually is trying to do the whole your own key decryption itself. You can see this has been rejected because I have blocked that particular key uh, for decryption purpose, right? So if I enable the key back, right? So if I unblock the key itself, right? So we for once it's enabled synchronized, then we go back to this same console, right? And then I'm trying to download this file again. You can see this file is not downloadable, right? So yeah, I think that's just a very quick demo. I guess I want to run through right now. Then the AWS key store is again AWS is calling the CipherTrust Manager, and yeah, so the encryption and decryption is successful, right? So I think, as I mentioned, the strength of this the solution is basically it can be applied to most of the AWS services, right? And then basically, customer has really a strong control of the keys, and that the encryption really cannot happen without customers' permission, right? So AWS no longer cache the key in the key store like BYOK case. This is one step up in terms of security and protection. Right. So I think today I'll probably just run through that as the first step, and I'll probably run through how is this being set up, and how is the connection being set up, and also the key store being created in the next session. But I guess for now, I think I'll just do this quickly because yeah, of the time.